off. First off, let me introduce myself. Hello, my name is Lance Zurich, and today I'm going to take a brief look at the two special curriculum-based sets from Studica that are designed for introducing students in middle schools, high schools, and homeschools to the fundamental principles behind mechatronics. Now, both of these sets are designed for conducting a project-based class, and that's essentially where students will be required to design and build a series of original prototypes based upon their own research and activities. And each of these sets includes standards-focused curriculum created especially for Studica by noted educator and STEM expert Tom White. So today we're going to start off where so many technology-focused presentations for education seem to start off these days, and that's with the skills gap that exists. Now, when you hear someone reference the skills gap or the need for better STEM education in the schools, STEM, of course, being an acronym which stands for Science, Technology, Engineering, and Mathematics. What they're essentially talking about when they mention this skills gap is the urgent need to prepare our students with the backgrounds they're going to need to successfully compete in the job market that they're going to be graduating into. Now, in the employment market that once greeted our grandparents, or even perhaps maybe our parents, a good work ethic, a strong back, and being able to take direction might have been enough to land a good paying job where many of the technical aspects could be learned on the fly. But now students must be prepared to enter a world that is increasingly focused on programming, automation, and IoT, and rapid advances in all aspects of technology. So in short, students must be able to demonstrate technical literacy and aptitude if they hope to compete and succeed. Now, this is, of course, why so much of the emphasis in education over the last decade has been on developing STEM skills. Now, every new advantage we enjoy, such as the tablets and the smartphones that we all use daily, was created because of individuals who helped to make those advances. Now, countries all around the globe, countries like China and India and so many others, are making major strides in developing new technological advances, and they're preparing their own students to take their place in the future workforce. Here in the United States, we also need to prepare the next generation of graduates with the skills, the mindset, and the habits that will enable them not only to secure jobs, but to be part of the next wave of advancements we rely on to stay competitive on the world stage and to maintain our stature as a world power. Now, as I have no doubt that anyone attending a webinar like this is already in agreement about the importance of STEM and technology-focused programs, instead what we're going to do right now is we're going to move right along to the main topic, which is, of course, mechatronics. Now, mechatronics has been called the science of intelligent machines. It's a study that focuses on electrical systems, control and mechanical systems, robotics, the Internet of Things, and computer science. All extremely important subject areas for students to be exposed to, and all skill sets that are highly prized in today's technology-focused job market. But just how prized am I talking about? Well, per the website careerexplorer.com, the average salary for a mechatronics engineer in the United States is currently around $96,980 per year. That's pretty impressive. So while, of course, students who go on to secure these prized career positions are the ones who prepare themselves by pursuing the proper post-secondary coursework, they do need to start developing the habits and the career focus as early on as possible, in high school at least, if not even in middle school. Now, the dilemma for educators, whether in the classroom or in the homeschool environment, is finding ways of introducing this kind of subject matter to students in a way that gets them interested and involved in the learning process, and not just involved in memorizing obscure facts and ideas, only to regurgitate them for a few tests, then, just flush them from their memory. To really best help students to be successful and to really encourage them to consider pursuing further education subject matter like this, educators need to be able to present the material in a way that makes it relevant, which means answering the eternal student question, well, why do we need to know this? And it also needs to be engaging in a way that holds students' attention better than rote textbooks and lecture presentations, and it has to be something that has visible real-world applications in which the students can get involved in doing things hands-on. Now, it's with this dilemma in mind that we created the Studica Mechatronics programs. Now, these two special sets, one of which is designed as an introduction to the world of mechatronics, and one of which is intended to be essentially a standalone class dedicated to the subject. Both of these sets were created to provide all of the materials in one place that educators will need to enable them to offer a project-based class that is relevant, engaging, realistic, hands-on, and which is crafted to meet the most current academic standards. Each of the two Studica Mechatronics program sets has its own detailed, day-by-day curriculum document, which was created especially for Studica by noted educator and STEM expert Tom White. Now, the curriculum comes as a downloadable PDF, which is available for free with the purchase of each set. Now, this curriculum is designed to align to the most widely accepted academic standards currently in place in the United States. The curriculum is also designed for offering a project-based learning program. And what this means is that solving the problems that arise in each unit requires the students to be actively involved in the research, involved in the design, the trial and error experimentation, and all the activities, and in the building of actual working prototypes that will provide the required answers. And students won't do this alone. They'll be asked to work in small groups or teams of 4 students each. This will help them to develop the soft skills that students also need, maybe just as much as they need to develop the technical skills. And by soft skills, of course, we mean things like communication skills, teamwork, adaptability, problem solving, and of course, leadership. And finally, with the exception of some very affordable programming software, each set includes all of the physical building materials every one of these groups is going to need to enable it to address all the design projects presented throughout the course of the curriculum. Now, the curriculum is designed to enable teachers of all backgrounds, even teachers from non-science or technology-focused disciplines, and we want to stress that. It's designed to enable teachers from all sorts of backgrounds to have the information they need at hand to properly prepare them for conducting the activities and to increase their own comfort in presenting this material to their students. The curriculum is designed to be clear and easy to follow, providing a clear roadmap for student learning. Various supplemental materials are included both in link form throughout the curriculum and also at the end of each of the units. There are also special tutorials on familiarizing students or teachers with the building system they will use to address the projects presented in each of these units. The units in the curriculum are designed as a series of projects. Now, each of these projects is presented to students in the form of an engaging real-world style scenario. And in this case, it's where students must work together in small teams, again, 4 students per group, to create a solution. The project units each contain embedded academics. And at the end of each unit, the students will be required to make a formal presentation of the prototype they've created to address that unit's real-world scenario, and they have to explain their reasoning. There is a technical literacy task driven by each of these projects. As they work to address each project, students will acquire the knowledge they need through inquiry and exploratory research. Science, math, and technical skills are acquired through the carefully designed enabling activities. Now again, as required by each project, students will be asked to create original prototypes and any required programming-based solutions, and also to maintain detailed documentation during the entire process. Now, as I mentioned earlier in this presentation, the curriculum that accompanies each of the Mechatronics program sets was created especially for Studica by a man named Tom White. Now, Tom is a noted educator, has been involved in teaching STEM and technology since the 1970s, and he's known for designing programs for educational institutions and for industry. In fact, as an expert in hardware and software integration, Tom was pivotal in introducing things like CAD, CAM, control systems, digital control, additive manufacturing, and other such topics to the classroom. Now, currently, Tom is the Director of Technology for STEM curriculum at the globally recognized industrial manufacturing company, Siemens. Now, the standards addressed in the Studica Mechatronics program sets are the most widely accepted standards currently in place in the United States. These include the college and career readiness standards for mathematics, reading, and writing, as well as the next generation science standards for K-12 and the standards for technological literacy. Now, as I've mentioned a few times, the programs are designed to be project-based. Now, this approach helps to answer those eternal questions, why do we need to know this, and of course, where will we ever use this, that too often arise when students are presented with technical subjects that just might come across as too abstract in their purpose. Here instead, students get to see firsthand why these things are necessary and where they're useful. The concept of working in the small groups to solve the project problems also helps students to develop the high demand skills that employers look for. Things we were talking about before, the soft skills like communication, analytical skills, quantitative skills, flexibility, adaptability, and problem solving. Now, in this project-based format, subjects are integrated, meaning the math is integrated with the reading and the writing and so on, which is ideal for STEM education. And also, because of the manner in which students must approach each subject, meaning with the research, the testing, and the group give and take, to provide just a few examples, this all helps to allow for a much deeper exploration of problems than traditional teaching methods might allow. Now, the projects presented in each unit are also designed so that if you have several groups working on the same project at the same time, you should see variations in their prototypes and their solutions. Now, this can be, of course, because of creativity or differences in research and approaches taken by each group. But in any case, students can see firsthand that problems can have many different answers, and that often there is not one right answer and only one answer, that there can be many answers. Each project in the curriculum presents students with the opportunity to plan, to organize, and to conduct research. The enabling activities that students are asked to engage in provide them with the skills and knowledge that they need to draw on to complete each project just in time. And students will be required to do extensive research as they complete these projects. Research that is utilized in the design, in the prototyping, the testing, the evaluation, and the redesign phases of each of these solutions. And once again, the Studica Mechatronics sets are designed specifically for students to work in groups. Each set contains enough materials for a team of 4 students. The team approach, as stated before, helps to promote soft skills such as communication, the ability to work well with others, and leadership. And the sets offer an easily scalable approach. Just divide the number of students in your classroom by 4 to determine the number of sets needed for each class. And once again, everything you need to conduct the program, with the exception of the programming software, which can be purchased in either single user licenses or affordable school site licenses, is included inside of each box. Everything else besides the software is inside of each box. Now, access to the free curriculum download is included with the purchase of each set. Whether you buy 1 set or 20, immediately you get access to that curriculum. Now, also included are all of the building materials which students will use in the creation of each of their prototypes. Now, these materials are taken from the unique Fisher-Technic building system, and among the components included in each of these sets are 2 robotic controllers and 2 power supplies. Now, that probably brings up the question for those of you who aren't familiar with Fisher-Technic, what exactly is it? Well, I'm going to provide you with a little bit of background. Fisher-Technic is a flexible and innovative construction system. Now, unlike other popular construction sets that are designed to simply stack, Fisher-Technic was created with more of an engineering mindset. The core building block in the Fisher-Technic system is unique in that it allows attachment from all 6 sides, and thus it allows for almost limitless design possibilities. Now, many of the parts in the system are designed to slide together and lock in place, and the hundreds of different parts available will also help students to address very specific design needs. Just to give you a little more background, Fisher-Technic was created back in the 1960s by German inventor Arthur Fisher, who's noted for countless innovations used in construction and the automotive industries. Now, Mr. Fisher, at the time of his death in 2016, held more patents in his name than Thomas Alva Edison had amassed during his own lifetime. Well, besides Fisher-Technic, Mr. Fisher was the inventor of synchronized flash photography, which was back in 1949, and he was also the creator of the expanding nylon wall plug, which is of course used in conjunction with a screw or a bolt to help anchor heavy objects to walls. We probably all use them. Now, his company, the Fisher Group, employs thousands of individuals worldwide, producing many variations of fastening devices used in building construction, as well as components used in the automobile manufacturing process, and they also provide consulting services related to automated processes. With that all said, let's begin looking at each of the two individual sets. We'll first start off with the Studica Introduction to Mechatronics Program set, or for those of you who may like acronyms, you can refer to it simply as SIMP. This set is designed to help provide a well-rounded, comprehensive introduction to the core concepts of mechatronics. Each set includes access to a free download of a 242-page curriculum document entitled Mechatronics Fundamentals, written by Tom White. Now, the curriculum contains enough activity material to fill approximately 45 academic hours. With this in mind, we recommend this program set for insertion into regular related class activities, or as a short class unto itself, for after-school program use, or of course, for homeschool use. The curriculum created for this set is again standards focused, again using the academic standards most widely recognized in US-based education today, and it's designed for offering a project-based program. The set is designed for use in middle school or high school classes, or again for addressing the same grade levels in a homeschool environment. Each set contains a collection of over 700 Fisher Technic building components, and this will be everything from gears, wheels, axles, blocks, sensors, and so much more, as well as 2 robotic controllers and 2 power supplies. As I've mentioned before, robotic control software is required and is sold separately, and we'll address that a little bit later in the presentation. Now, the curriculum for the Studica Introduction to Mechatronics Program set consists of 6 project units, and they are as follows: sketching and documentation, simple machines, mechanical systems, basic electricity, conversion and storage of energy, and an introduction to control systems. Now, there are also activities included to address the following areas that come up during the course of the curriculum. Includes sketching, linkage diagrams, schematics, Ohm's law and power, pneumatics, flow charts, using software and robotic controllers, sensors such as the digital switch and the digital photo transistor, open loop and closed loop programming, digital branching, analog sensors such as the photocell LDR, analog branching, analog sensors such as the NTC resistor and the potentiometer. Now, before we go further into the structure of the curriculum, let's first look at what's covered in the second set. Now, the second set is the Studica Teaching Applications of Mechatronics Program, and the acronym that I use for this one is STAMP. Now, this set is designed for those educators and homeschoolers who wish to provide a more in-depth exploration of the fundamental aspects of mechatronics. Now, the set includes access to the free downloadable 401-page curriculum document, in this case entitled Mechatronic Applications, again by Tom White. And the activity materials in this curriculum document, when used in conjunction with the contents of this set, is designed to fill approximately 180 academic hours. So essentially, this set can be seen as a more expansive version of the material touched on in the previous set, and it's designed for those educators who are able to dedicate a daily class period of approximately 50 minutes a day for 5 days a week, or the equivalent every week for a full academic year. Now again, this set is designed for offering students a standards-focused, project-based learning experience and is designed for use in middle school, high school, or for addressing similar grade levels in a homeschool setting. The materials in this set consist of a selection of over 1,200 Fisher Technic building components, and once again, this will include a wide array of gears, blocks, sensors, axles, and many other pieces, as well as 2 robotic controllers and 2 power supplies. As I've said before, software is required for this set, and we'll talk about that shortly. Now, there are twice as many project units included in the Studica teaching application of Mechatronics program set as in the set that we previously discussed. Now, these project units include units on the following: sketching and documentation, simple machines, mechanical systems, basic electricity, and then project units focusing specifically on the creation of a garage door, an elevator control, an automated pneumatic clamping system, an automatic pneumatic feeder system, a conveyor with a counter, a robotic control, a sun tracking solar panel, and a color sorting machine. And again, during the course of the curriculum, links are provided for various activity materials for students to utilize. And these include sections on the following: sketching, linkage diagrams, schematics, Ohm's law and power, flow charts, using the programming software and the robotic controllers, open loop programming, sensors such as the digital switch and the digital photo transistor, closed loop programming, digital branching, logic gates, combinational logic, edge triggered versus level triggered, pneumatics, variables, positions, recording positions, creating a graphical user interface, working with analog sensors such as the photocell LDR, the NTC resistor, the potentiometer, and working with data. So now that we've had a look at how each set differs and the specific subject matter covered by each of these sets, let's now look at exactly how the curriculum itself is set up and structured. Now, both versions of the curriculum share the same format when it comes to the structure of each of the project units, and as already discussed, each version will include tutorial materials, activity materials, standards, and also supplementary materials. Now, in each case, the curriculum is also designed to be turnkey. And what I mean by that is that besides the elements I just mentioned, excuse me, each unit is designed in such a way as to enable teachers from all types of backgrounds, and again, that includes non-science and non-technology focused backgrounds. It's designed to enable teachers from all types of backgrounds to quickly become comfortable with delivering material simply by reviewing each section before they present it in class. Each unit includes the following sections: an introduction, the purpose of the project, the concepts, an outline, standards, assessment rubrics, the essential question, a student scenario, a daily plan, vocabulary, and various resources. Next, we're going to look at each of these sections a little bit closer. Each unit starts with an introductory section and the purpose of the project. Just as you would likely gather from that name, this is the section that provides a brief description of the topic that will be explored in the coming days and activities. This is also the section that seeks to clearly spell out to students the answer to that eternal question: so why are we doing this? The next section focuses on the concepts to be addressed in each unit. And these are the broad ideas that will be explored in the unit and the core information that students should take from this project that will be essential for them to understand and utilize, but not only today, but essential for them to draw on as they move forward in STEM-related fields of study, and we would, of course, hope STEM-related careers. After this, we see the outline. Now, this is the section where we drill down more specifically to what will be addressed in the unit. As the example shown on the screen now is taken from the unit that addresses aspects of programming, you will see that we touch upon areas such as the methods for writing programs, such as flow charts or word problems, various program characteristics, for example, open or closed loop, gets into branching, digital, analog, subprograms, and so on. The next section of each project unit focuses on the specific academic standards which will be addressed in that unit. And again, as you will see, this includes the college and career readiness math standards, reading standards for literacy in history and social studies, writing standards for literacy in history, social studies, science, and technical subjects, the National Research Council's Next Generation Science Standards for K-12, and the standards for technological literacy. Each project unit also contains rubrics, and this will include both the rubrics for the specific project unit being covered, as well as general rubrics for literacy tasks. This is followed by the essential question, and this can essentially be thought of as the big picture question that will be focused on in each of the smaller individual activities, and of course, all the aspects of the larger projects which the students are going to be asked to complete in this section. The student scenario, next up, is where the specifics of the project to be addressed are finally detailed, all of which is presented in the context of a real-world style scenario where students are presented with a problem which they must work in groups to solve together. Now, this problem will require students to design a unique and original answer, usually in the form of a working prototype, along with whatever programming may be required. Now, if you look closely at the student scenario shown on the screen right now, you will see that the project in this specific unit has each group of students taking on the role of a design team employed by a firm that manufactures garage door openers. In this case, students will have to design a specific type of control system for a new line of garage doors. The manufacturer's requirements are spelled out, such as, in this case, the use of limit switches, meeting certain safety codes that require a method for sensing if anything is in the way of a closing door, and the incorporation of an automatic light. Now, as discussed previously, each group of students will be tasked with creating both the unique and original prototype, and in this case, of course, that's the garage door opening system, as well as the programming needed to control that prototype. Now, along the way, they will be required to document the entire process in both the design notebook and a digital engineering journal. And they have to note all the research that goes into the project, all of the trial and error experiments. They have to keep copies of all design sketches and revisions, and so on. Anything that they're creating on the way to finishing their project, they have to keep there and document. And at the end of each project unit, each of these groups of students will be required to make a formal presentation in front of the class, during which they demonstrate their prototype and their programming in action, much as they would be required to do by an actual employer or client in the real world. So after that student scenario, we get into the daily plan. And this is the section that spells out clearly, both for students and the teachers, what's going to be expected of students, how the teacher will conduct that day's classroom activities, and what specific subject matter is going to be covered. Now, some days may involve discussions, other days may involve research, or, for example, building small projects that will help provide the building blocks that students will draw on to complete their larger projects, as described in the student's scenario. But in short, you can basically think of the daily plan as a roadmap. Now, you'll see too that along the way, as different aspects are addressed in each day's activities, such as, for example, what is required in a design notebook, or how to use the control software, or working with the controller, or with flowcharts, or what have you, that as these things come up, there are links to sections that will provide further instructions and information on each of these areas. So this way, if the students had a question about it, they can, of course, click on it and go to a section that'll tell them more. At the end of each unit, after the daily plan, is a section containing vocabulary. And these are, of course, important words and terminology introduced during the project unit, as well as the selection of important resource materials. Now, these resources can contain a mix of different types of material, and this can include everything from carefully vetted websites and video links to, for example, PDF documents or PowerPoints or what have you. Now, besides the project units, each version of the curriculum also includes a section devoted specifically to learning how to use the Fisher-Technic building system. And this will include information on how the various parts fit together using the pin and groove assembly method, identifying the various types of parts, from the various types of girders and blocks to different sorts of axles, gears, rivets, and much more. Students are also going to be asked to build a simple model to help familiarize themselves with the system before they move on to the projects in each unit. And as learning about and maintaining proper documentation is one of the areas stressed in the course of the curriculum, there is a section which details just what defines each type of documentation listed on the screen now and what is required for each of those. And of course, as the process of conducting a project-based class activity may be unfamiliar to some teachers, there's also a section that discusses specifically project-based STEM education and its benefits. So let's just review each set again briefly, but this time with pricing. Now, first we have the Studica Introduction to Mechatronics Program set, designed as a standards-focused, project-based introduction to the core concepts of mechatronics. The program is conducted with the use of a highly detailed 242-page curriculum document entitled Mechatronics Fundamentals, again written by noted educator and STEM expert Tom White. The curriculum, when used in conjunction with the materials in this set, will provide educators with enough material to fill approximately 45 academic hours. It is again designed for those educators who wish to offer short classes, after-school programs, or for homeschool use. The standards-based materials designed for use in middle schools and high schools, as well as, of course, by homeschooling parents seeking to address STEM and mechatronics for these specific grade levels. The physical materials in each set include a selection of over 700 components from the Fisher Technic building system. And again, this includes everything from the sensors, blocks, gears, and more that will be used to construct the prototypes that are going to be required in each of the project units of the curriculum, as well as 2 robotic control units and 2 power supplies. Software, again, is required, sold separately, we'll talk about in a second. Again, each set is designed for use by teams of up to 4 students at a time, with pricing starting at just $6.99 for a single set, and classroom-sized quotes for students for 20 students and more are available upon request. So you can just ask us and we'll be happy to provide classroom quoting. The other set, of course, is the Studica Teaching Applications of Mechatronics Program set. Again, this is designed as an in-depth, standards-focused, project-based exploration of fundamental aspects of mechatronics. The program is again based around a highly detailed 401-page curriculum document entitled Mechatronic Applications, again written by noted educator and STEM expert Tom White. This document, like the one for the previous set, is a downloadable PDF document which can be accessed with the instructions included inside each box. When used in conjunction with the building components included in this set, the curriculum is designed to provide enough activity material to fill approximately 180 academic hours. Again, this is designed for those educators and homeschoolers who are willing and able to offer a daily dedicated class period of 50 minutes a day, 5 days a week, or the equivalent on this subject for a full academic year. Again, the standards-based materials designed for use in middle schools and high schools, as well as for homeschooling parents seeking to address STEM and mechatronics for these grade levels. Each box contains an assortment of over 1,200 components from the Fisher Technic building system, again including blocks, girders, gears, sensors, axles, and so much more, as well as 2 robotic control units and 2 power supplies. Software is again required, talk about it in a second. And again, each set is designed to provide enough materials for 4 students at a time, with pricing for a single set starting at just $799 each. And of course, if you need classroom-sized price quotes for 20 students or more, just contact us and we'll give you those special pricing quotes. Now, as I've mentioned several times that software is required, let me address that right now. The software in question used is the Fisher Technic RoboPro software, which is graphic programming software. What I mean by that is that it uses basically a flowchart style design using various icons which students arrange to link to create the programs used for each of the models in these sets. Now, graphic programming software is ideal for teaching the fundamentals of programming to users of all levels. And the pricing for this starts, a single user license is only $36, and an unlimited single site school license, meaning that you can have unlimited users at a single site or building with this license, when that means it could be 1 computer, 100 computers, or more if you have them in the building. And the cost for that site license is only $120 per site license. And I should note here that these are not subscription prices and these are not annual licenses. These are non-expiring licenses you can access as long as you have the software disk that comes with each of these, and as long as you're able to install this software on a computer that has compatible Windows-based desktop or laptop with Windows version 7, 8, or 10. So as long as you have that, you can use this. So this is the period where we would open up the floor to questions. I see that I have a couple typed in, so let me see what I have here. Hang on a second. I have yet to teach mechatronics, but will in January. When the students take the certification exam, are they allowed to use the flip book? Well, not really a flip book per se here. There's, as I mentioned, there's curriculum here that is provided to the teacher, can be shared with the students. But as far as for any kind of certification exam, I would probably say that no, you probably wouldn't use it with that. Also, it says, I was trained by Festo for NC3 in March. Is this the same program as Studica? No. And can you please cover the set prices again? Zoom stopped working. Sorry, Todd. I'm going to back up the screen for a second just to go there. The first set, the introductory set, that's the one that essentially offers 45 plus academic hours. That is $699 per set. Again, 700 components, 2 controllers, 2 power supplies. So that's $699 per set. If you need a larger quantity, of course, we have quantity pricing, so we can help you out with that. And on the second set, that's the more comprehensive set that's designed to cover 180 academic hours, 401-page curriculum document, 1,200 Fisher Technic components, 2 controllers, 2 power supplies. That one is $799 per set. And of course, classroom pricing is available upon request. So hopefully that takes care of that. Anyone else have any other questions? Going once, going twice. If you're thinking about it, you can even just type in a letter so I know that you're thinking about it. What I will also say, well, I will go, you can still ask a question. I'm going to go ahead to the next screen that has my email address. If you want to take the next step, and whether that step be requesting a quote from us, if you would like to speak with a dedicated educational representative, you can call us directly. There's our number, Studica US. It's, of course, a toll-free number, 888-561-7521. If you have general questions about the program, getting quotes, what have you, you can email us at info@studica.com, studica.com. If you have specific questions for me regarding Fisher Technic, any aspect of Fisher Technic, any aspect of this Mechatronics set that we reviewed today, or any of the Fisher Technic products or simulation models, which I also deal with, anything like that, any questions that came up during the presentation that you didn't ask right here, you can email me, Lance Zurich, so lance.zurich@studica.com. I see one more question. I'm going to get to it just a second. So once again, lance.zurek@studica.com. The question from Todd. I used this project 6 years ago or so. Have the pins on the ends of the aluminum beams been revised? No, they have not been, but if this became an issue for you, Todd, we do have replacement end pieces for that. So you don't have to replace the whole beam. You can just get the little end nubs. I should also say that any of the spare parts that are used in this set or any of the other sets that we offer that use Fisher Technic, that spare parts are orderable, whether you need 1, 100, 32, what have you, you can buy those individually. But if you just needed the little end pieces, the little black end caps for the aluminum things, we do sell those, so not an issue. Anyone else? Anyone else who has any questions, feel free. I won't go anywhere as long as you ask questions, but if you stop, then I will. We are also recording this webinar, so if anyone did miss anything, I know at least in this area of the country, we were having some issue with severe weather. I know there was the threat of power outages, so if anyone did miss any of this, we will have a recording available, and Christy will probably be sending you a link to that in the next day or two. But if anyone else has any other questions, going once, going twice. We don't have to see that screen. I will just say thank you very much for taking the time to attend today. We do appreciate you coming along for this. If you do have any questions at all, again, the 2 email addresses are up on the screen. You can email me directly. Any questions you had specifically about the program or Fisher Technic or any of the things we do. Otherwise, we do look forward to hearing from you. We look forward to seeing you again. I would ask you also check our list of webinars on the Studica website. We have quite a few every week on Fisher Technic and Mechatronics and IoT and all sorts of good stuff, automation and control and what have you. So please check those out, and we look forward to seeing you again soon. Thank you and take care.